Here again we have an important question. You have to explain as to why N-methyl 3 and N-SI-methyl 3 whole thrice are not isostructural. So for this, let us first draw the diagram. NMe3, MeCH3 group is something like this. This nitrogen has 5 electrons in its outermost shell. With 3 electrons it forms bond with 3 different carbon atoms of methyl to complete its octet. Now the steric number is equal to 4, therefore hybridization is sp3 and the structure is tetrahedral. We can draw this as nitrogen, there is a lone pair at top, CH3 group here, CH3 group here and a CH3 group here. Now when we take the case of NSiMe3, what happens is that this nitrogen, let us draw the diagram like this, Si, 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 and there are 3 CH3 groups on this methyl. This nitrogen has a lone pair of electrons. Now what happens is that this lone pair of electrons does back bonding in the vacant d orbital of Si. This is a very important point. Si has vacant d orbital, due to which this lone pair of electron does back bonding in the vacant d orbital of silicon, which was not available in carbon. So an important point to note here is that silicon has vacant d orbital, whereas carbon does not have that. Therefore this lone pair gets a chance to do back bonding over there. Now this lone pair of electron does back bonding, and it can do with any of the 3 silicon atoms, because all the 3 silicon atoms have a vacant d orbital, due to which a partial d bond character is developed. SiMe3 and SiMe3, it sometimes does back bonding with this atom, sometimes with this one, and sometimes with this one. Therefore there is a partial d bond character in each of the bonds, due to which these two are clearly not isostructural. So we clearly explained as to why these two molecules are not isostructural, because carbon did not have a vacant d orbital, whereas silicon has a vacant d orbital in which the lone pair of nitrogen can do back bonding.